So now we get into a more or less complicated subject of the algebra of matrices, but I'm going to make it simple and quickly because I'll get into this subject later on. Okay, so what is and this video is about this, what is an algebra of matrices? So an algebra of matrices is, so we have a collection, I'm going to use this C, okay, a collection of matrices, okay. So we have here a set of matrices. We have matrix A, B, C, etc. Okay. I'm leaving this space here because I might get back here or not. Okay, so we have this of course a non-empty. If the set is empty, this makes no sense. So we have a set, a bag of matrices, and it will be called an algebra, a very fancy word and dangerous word too, if this set is closed under the operations of adding. So it means that if I pick, for instance, matrix A and I add another matrix from this set, matrix B, I get a matrix D, and this one is here too. Okay, so but this, I'm adding matrices. So if I have this collection, a collection of matrices, and they are closed under matrix addition, and if they are not only closed under the operation of matrix addition, but also of scalar multiplication, meaning I pick these matrices, I pick scalars from a field, and every time I scalar multiply, I multiply one matrix by a scalar, this one is still inside this C here. Okay, if that happens, so I'm not going to use this one. I'm going to use this small thing for scalar multiplication. Okay, and so I'm going to use this one for scalar multiplication, and I have to use this one, for instance, for matrix multiplication, meaning if I pick matrix A, I multiply matrix A by matrix B, and I get matrix E, and E is also here in this set. So if this happens, if I have a set of matrices closed under matrix addition, closed under scalar multiplication, and closed under matrix multiplication, then we can say that this is an algebra of matrices. Let us pick an example of, let us say, AN, matrices AN. All matrices 2 by 2 or 3 by 3 or 4 by 4. Okay, is this the collection of square matrices? Is it an algebra? Well, let us see. Point number 1, AN, the set is not an empty set because there are matrices of square matrices of every dimension. Okay, so it's a non-empty set. If I add two n square matrices, I'll get an n square matrix. Okay, so it is closed for this operation, right? Okay, so the set exists, is not empty. Point number 2, square matrices. If I add two square matrices, I get a square matrix. so it's closed under addition. If I multiply a square matrix by any scalar, I'm getting a square matrix too, right? If I have, for instance, a 2 by 2, 1, 2, 3, 4, and I multiply this by this matrix by 5, I'll get a square matrix, the same dimension, right? So it's closed under the scalar multiplication operation. And if I multiply two square matrices, of course, same dimension, right? I'm getting the matrix I get here is the same dimension and is also a n square matrix. Okay, so any set of n squared matrices is an algebra. Okay, for instance, the 2 by 2 matrices. So if we get the 2 by 2 matrices, they are closed under addition, closed for scalar multiplication, closed for scalar multiplication, closed for matrix multiplication. So the space with matrices dimension 2 by 2 square matrices is an algebra. Okay, an algebra of matrices.